Today the topic is plasma arc machining. The plasma arc machining or plasma arc cutting or plasma processing a high velocity jet of this high temperature ionized gas is directed onto the workpiece surface by means of a well designed torch. This jet melts the metal of workpiece and displaces the molten metal away from its path. The heating of workpiece material is not due to any chemical reaction but on account of the continuous attack of electrons which transfer the heat energy of high temperature ionized gas to the work material. This process can therefore be safely used for machining of any metal, including those which can be subjected to chemical reaction. As shown in this, the diagram is a plasma arc machining. One of it shows the electrode kept in between the two insulation. The insulation of electrode, the process inside the chamber of more than 75 inert. The gas mixers enter into the surface chamber. The power supply, DC power supplies, workpiece. These are the black identified nozzles. The temperature of ionized gas stream. Next one is a electrochemical machining process. It is an extension of electroplating with some modifications, but in a reverse direction. Thus, electrochemical machining can be described as controlled anodic dissolution at atomic level of workpiece. That is, electrically conductive by a shaped tool due to flow of high current at relatively low potential difference through an electrolyte, which is quite often water based on neutral salt solution. These are the examples and image of ECM unit. The maximum high voltage cable 30 kilowatts direct current. This is a cathode grid. This is an anode. Optical viewing systems, valve, electron stream, magnetic lens, deflection, view porting, vacuum chamber, workpiece, work table, high vacuum pump. These are the electrochemical machining's initial stage of ECM tool, workpiece, electrode, steady state of SEM. Electrochemical machining, the workpiece, tool, insulator coating, DC power supplied, positive and negative thermal. Mechanical energy based process, abrasive jet machining, water jet machining, ultrasonic machining, equipment used, material removal rate, variations in technique used, applications. Principles of abrasives. Abrasive machining process, a high stream of abrasive particle mixed with high pressure of air or gas injected through the nozzles. The workpiece to be machined. Construction of abrasive jet machining. Hooper, regulator, pressure gauge, control valve, hose, nozzles, abrasive jet, workpiece, mixing chamber, vibrations, gas supplies or air supplies, the pressure gauge, the gauge regulators. Both are mixed inside the mixing chamber. It consists of a mixing chamber, nozzle, pressure gauge, hooper, filter, compressor, vibrating device, regulator. The gases used in the process are nitrogen, carbon dioxide or compressed air. The abrasive particles used in this process are aluminum oxide, silicon carbide, glass powder, dolomite and specially prepared sodium bicarbonate. The aluminum oxide general purpose abrasives, and it used in size of 10, 20, 25 micron. The silicon carbide is used for fast cutting or extremely hard material. The size used to 20, 25 microns. Dolomites 200 grams, 200 grid size for the suitable lighting and cleaning etching. Glass powder of diameter 0.30 to 0.60 mm are used for light polishing and deburring.